Yes, I welcome you guys to this splendid day. And our today's lesson is very, very, very interesting. We are going to look at Le Chatelier's principle and the factors that affect equilibrium of reversible chemical reactions. These reactions take place, but we find out that there are some factors that affect them. Now, here comes a man called Le Chatelier. This man called Le Chatelier, his full name is Henry Louis Le Chatelier. As a simple background, he's a French chemist, right? And yeah, he was interested in looking at how the equilibrium of reversible reactions respond when a certain factor is changed. So this man called Le Chatelier's principle stated that when a system is in equilibrium and one of the factors affecting it is changed, the system will respond by minimizing the effect of change. Okay? In other words, this principle is very important because it allows us to shift an equilibrium to the side that you would like to favor. That's why we are saying that. It states that, right? When a system is in equilibrium and one of the factors affecting it is changed, the system will respond by minimizing the effect of change. That's all about Chatellier's principle. And we are saying that it is very important because it allows us to shift an equilibrium to the side that we would like to favor. Okay, so we are going to look at the effects of temperature, pressure, concentration, catalyst, addition of a noble gas, and many other things. So here I stated it in a different way that if a system is in equilibrium, if a system in equilibrium is subjected to any change, the equilibrium will shift, if possible, to a direction which causes an opposite change, which is very important. Or one can say if it is subjected to a certain constraint, we can eliminate this, or just constraints like hard time. Yeah, the system will that change will take place, and that change will try to remove the constraint. Now, the system cannot cancel to change, or rather, it can't cancel the change in the external factors, but it will move in a direction that will minimize the change. That's why I'm saying that, according to Louis Le Chatelier, okay, the principle enables us to shift an equilibrium to the side that we would like to favor. For example, you may be getting low grades in chemistry. Okay, that is a change. So there are factors that make you get low grades in chemistry. But after knowing those factors, there is going to be a change. Maybe you're going to revise, okay, so that you overcome that change, meaning that change of poor grade, the poor grades now, you will work hard so that you effect that change in an opposite direction, meaning that you're going to revise hard and improve your grades. So that's the same thing here about Le Chatelier's principle. If we subject any equilibrium to any change, the equilibrium will shift, if possible, to a direction which causes an opposite change. So this one now directly takes us to the factors that affect the equilibrium. And we are going to start with the pressure, effect of pressure. I will first explain, then I'll pick detailed questions which carry 2020 marks from past papers. And we discuss one of the questions. You're going to see how life can be very, very good. Okay, so now we need to know that pressure basically affects the equilibria of gases, okay? Because it has got a negligible change on the volumes of solids and liquid. So it only affects those reactions in which gases are involved. Another thing, you need to know that any reaction that occurs with an increase in volume is favored by a decrease in pressure. Okay, so that one we should know. Any reaction that occurs, all right, any reaction that occurs with an increase in volume, any reaction that occurs with an increase in volume, all right, any reaction that occurs with an increase in volume is favored by a decrease in pressure, and vice versa, meaning that a reaction, that is the first note that we can make. Another thing we need to know, that a reaction that occurs with a decrease in volume, is favored by an increase in pressure. These two notes are going to help us to know. We're saying that any reaction that occurs with an increase in volume is favored by a decrease in pressure. Then a reaction that occurs with a decrease in volume is favored by an increase in pressure. Now, we need to know that any changes in pressure of the system, okay, changes the position, meaning here when we are talking about the effects, we talk about the position of the equilibrium. Has it shifted from the left to right or from the right to left? Position of equilibrium. Then we talk about the rate of attainment, of that equilibrium. Then we also talk about effect on the rate constant, effect on the equilibrium constant, sorry. Effect of the factor on equilibrium constant. So for the case of pressure, okay, increase or decrease in pressure will change the position of the equilibrium from some direction to another direction. Number two, it will also affect the rate of attainment, but it won't have any effect on equilibrium constant. So let's see, using an example, let's revise the effect of pressure. Let's see the effect of pressure. Consider a reaction. We're having nitrogen gas plus hydrogen gas, giving us ammonia gas. So we want to see how the position of equilibrium, value of equilibrium constant, and the rate of attainment of the equilibrium is going to be affected if the pressure was decreased. If we decrease pressure of this system, what happens to those three? Position of equilibrium, rate of attainment of equilibrium, and equilibrium constant value. Now, you need to know from this equation, because we said that if the reaction proceeds with an increase in volume, then low pressure is required. Okay, so now we can see that one volume plus 3 volumes give 2 volumes. Okay, that is what you should first acknowledge. If we are told to talk about the effect when pressure was decreasing. You need to first acknowledge that 1 volume of nitrogen plus 3 volumes of hydrogen is giving us 2 volumes of ammonia. What does it mean? It means that the forward reaction occurs by a reduction in volume. That is what you need to first acknowledge. So a student would first say that the forward reaction, why forward reaction? Because we are going this side. So the forward reaction is favored, or the forward reaction occurs by a reduction in volume. Why? One can say since 1 volume of nitrogen reacts with 3 volumes of hydrogen to produce 2 volumes of ammonia. Meaning that since the forward reaction occurs with the reduction in volume, okay, hence it is favored by an increase in pressure. But by an increase in pressure. So what does it mean if we say by an increase in pressure? But now it means that for us, we expect an increase in pressure to favor forward reaction. But it means that if the pressure is being decreased, now it will favor backward reaction. We expect that since there is a decrease in volume, we needed a high pressure to shift the equilibrium to the right or to the forward reaction, to make it forward reaction. But the fact that pressure is decreased, now it is no longer going to shift this side, instead left. So we shall say that a decrease in pressure shifts equilibrium from left to right. Shifts equilibrium from left to right. Since, give me the reason, since the forward reaction occurs with the or by occurs by a decrease in volume. Which means that nitrogen will react with hydrogen to form ammonia, so that nitrogen will keep reacting with hydrogen to form ammonia, so that the equilibrium constant value is unchanged. So you can continue, because now we have to talk about the equilibrium constant. We've already talked about the equilibrium, the position of the equilibrium to shift from left to right. Then now talk about the rate, the equilibrium constant. So nitrogen, write the whole word, nitrogen reacts or will react with the hydrogen to form ammonia, react with hydrogen to form ammonia, so as to keep the equilibrium constant value, unchanged, constant value unchanged. So that to keep the equilibrium constant value unchanged. So we've already talked about the position and the equilibrium constant value. Then now we talk about the rate of attainment of the equilibrium. So the rate of attainment, of equilibrium, okay? The rate of attainment of equilibrium increases. Why does it increase? Because there are more gas molecules in a given volume, there are more gas molecules in a given volume, and these molecules are closer together. These molecules are closer together. Hence, there are more chances. There are more chances of successful collisions between particles. So equilibrium will keep being attained because will keep being attained, meaning the rate of attainment will increase simply because there are more gas molecules in a given volume. So molecules are close together. Hence, there are more chances of successful collisions between the particles. A student who writes for you this is not only distinct, but can even get a distinction. So the forward reaction occurs by reduction in volume. Hence, forward reaction, rather ends favored by an increase in pressure. But since they say that there is a decrease in pressure, it means that now, instead of forward reaction taking place, we shall have a backward reaction, meaning it will be shifting from right, rather from, it will be shifting from not left to right, but right to left. I'm sorry for this. It will be shifting from right, I have realized this. It will be shifting from right to left. Instead of having forward reaction, we shall have backward. This side is right, and this side is left. So it will be shifting from this side to this side. Okay. Now, after having known that, we have really talked about what happens when pressure is decreased. Now, what about when pressure is increased? Yeah, we've already said that the forward reaction occurs by reduction in volume, hence favored by an increase in pressure, implying that the system or the equilibrium will shift from left now to right. So let's write something about when pressure is increased. When pressure is increased. When pressure is increased, let's say increase in pressure shifts equilibrium from now left to the right. Why? Since the forward reaction occurs by a decrease in volume. So still the other statements are the same. Yeah, nitrogen gas will react with hydrogen gas to form ammonia, so that to keep the equilibrium constant value unchanged. So from here you can add whatever we talked about the other side. Okay, nitrogen will react with hydrogen so as to keep the equilibrium constant value unchanged. The rate of attainment of equilibrium increases because there are more gases present in a given volume, molecules are closer together, hence there are more chances of successful collisions between the particles, increasing the rate of attainment of the equilibrium. So that is all about that reaction. What of if you are given a reaction? Because in these cases, they give you a reaction and then they tell you to talk about what happens when pressure is increased or decreased. Here, you're having hydrogen gas being formed and iodine gas being formed. So, yeah, they can tell you to explain the how the position of equilibrium value, rather how the position of equilibrium, value of equilibrium constant, rate of attainment would be affected if pressure was increased. What about if pressure was increased for the case of this reaction? if we increase pressure for this reaction. If pressure was increased. Now you realize that for this case, 2 volumes of hydrogen iodide will produce 1 volume of hydrogen and 1 volume of iodine, which are 2 volumes of the products. Okay, now, since 2 volumes produce 2 volumes, it implies that increase in pressure has no effect on the position of equilibrium, since both forward reaction and backward reaction proceed with no change in volume. So that you would tell me that increase in pressure has no change on the equilibrium position, simply because the forward reaction and backward reaction all proceed with no change in volume, meaning that even if these are the ones reacting to give this, still 2 volumes will react to give 2 volumes. 2 volumes will dissociate to give 2 volumes. So even if you increase pressure or not, the position will not change, because the position changes when there is an increase in pressure, or rather when there is a change in volume. A system will try, the equilibrium will try to adjust itself so that to change or to overcome the change in the equilibrium having been caused. So there is no change in the position of equilibrium. Then the equilibrium constant still remains unchanged, but the rate of attainment will increase because there are more gas molecules present, okay, in a given volume. Molecules are close together, hence there are chances of successful collisions between the particles. So here, position with this, position of equilibrium doesn't change. No change in position of equilibrium. Equilibrium constant doesn't change. But rate of attainment of equilibrium increases. The rate of attainment of equilibrium has to increase. So that is all about the effect of pressure on equilibrium. So let's now look at the effect of concentration. Effect of concentration. I want to summarize this. Chap. Effect of concentration. Effect of concentration. So if we talk about concentration, still I'm going to consider a reaction whereby sulfur dioxide, okay, reacts with oxygen, okay, to form sulfur trioxide. Right. So here they can tell you to explain how the position of equilibrium, you have to note the thing that we talk about, how the position of equilibrium, talk about how the equilibrium constant value, talk about how the rate of attainment of equilibrium is affected if there is either, they can say, if more sulfur dioxide was added. If we add more sulfur dioxide, what will happen? 2, if sulfur trioxide was added. And 3, what would happen if we removing sulfur trioxide formed? So we want to talk about the effect of these situations to the position of equilibrium, equilibrium constant value, and the rate of attainment of equilibrium. So if we add more sulfur dioxide, it means that we are increasing the concentration of sulfur dioxide in the system. So one, I will say adding sulfur dioxide, right, increases the concentration of sulfur dioxide, increases the concentration of sulfur dioxide, okay? And excess sulfur dioxide, okay, reacts with oxygen, reacts with the oxygen. That excess sulfur dioxide will react with the oxygen to form or to liberate or to produce sulfur trioxide. In an exam, you have to be writing full sentences. Sulfur dioxide, those are two words. Sulfur trioxide, those are two words. So to produce sulfur trioxide, okay? So let's produce sulfur trioxide, produce sulfur trioxide, so as to keep the equilibrium constant value, the equilibrium constant value the same. In other words, being equilibrium constant, it has to be the same. So for it to keep the same, it means that sulfur dioxide will keep reacting with oxygen to keep producing sulfur trioxide. It would be constant like that. Okay. Now, what will happen to the equilibrium? The equilibrium will shift from right to left. Okay, and the equilibrium constant value will remain the same. So, equilibrium will shift from left to right because more of this is reacting with this to produce this. So we shall continuously keep producing the sulfur trioxide. So equilibrium shifts from left to right. Equilibrium shifts from left. It keeps shifting from left to right, and equilibrium constant value remains unchanged, Then now we talk about the rate of attainment of equilibrium. Since these ones will keep reacting, okay, and there are many gas molecules present, okay, so the rate of attainment will increase, right? Because you are even adding more, so there is constant collision. So we shall say the rate of attainment of equilibrium increases since there is an increase, in the number, of particles in the reaction vessel or in the reaction container or vessel. So we've talked about all the three. The fact that you have added this, the reaction will keep shifting left to right, because excess sulfur dioxide will keep reacting with oxygen to form sulfur trioxide. Yeah. Then, how about when sulfur trioxide was added? If in this reaction we add sulfur trioxide, what would you expect? It means that the concentration of sulfur trioxide will increase, and the excess sulfur trioxide now will dissociate to produce oxygen and sulfur dioxide. So we shall say that adding sulfur trioxide increases the concentration of sulfur trioxide. So the concentration of sulfur trioxide increases. The concentration of sulfur trioxide increases, and excess sulfur trioxide dissociates to produce excess sulfur trioxide dissociates to produce sulfur dioxide and oxygen. All right, so as to keep the equilibrium constant value the same, as to keep the equilibrium constant value the same. Okay, increasing the concentration of this will make this keep dissociating to produce oxygen and sulfur dioxide. As that dissociation keeps taking place, it means that the equilibrium constant value has not changed. So in this case, it means that the equilibrium will shift from right to left. So you will say equilibrium shifts from right to left. Now the equilibrium will shift from right to left. Then what about the equilibrium constant value? And equilibrium constant value remains the same. So if the equilibrium constant value remains the same, then now all remains unchanged. Then now we talk about the rate of attainment of equilibrium. The rate of attainment of equilibrium increases because there is an increase in number of particles in the reaction vessel. Since you're adding more sulfur trioxide, it means that the reaction vessel has got more molecules. So you say rate of attainment of equilibrium increases. Why? Because the number of molecules in the reaction vessel increases or increased. So you can add it there because the number of molecules in the reaction vessel or the number of particles in the reaction vessel increases or increased. Now, part 3, they want us to talk about what if sulfur trioxide is removed. So if sulfur trioxide is removed, it means that the sulfur dioxide will react with the oxygen to replace the removed sulfur trioxide. Okay, keeping the equilibrium constant value unchanged. Right, and there the equilibrium will shift from left to right because these ones will be reacting to replace what has been removed from the right. So removing sulfur trioxide, one will explain and say removing sulfur trioxide, okay, makes sulfur dioxide and oxygen to react so as to replace the sulfur trioxide removed. Okay, and that one keeps keeping the equilibrium constant value and equilibrium constant value unchanged. Okay, then we can say equilibrium shifts from left to right. Now, the rate of attainment of equilibrium we reduce. The rate of attainment of equilibrium reduces because you removed something. So you removed sulfur dioxide. So the rate of attainment of equilibrium reduces since there is a reduction. Since there is a reduction, in the number, there is a reduction in the number of particles. There's a reduction in the number of particles in the reaction vessel. So the whole factor was about concentration. When you add something, you increase its concentration. When you remove something, you have reduced its concentration. So that is the trend. Then allow me to take you to the third factor, which is temperature. This factor of temperature, yeah, we need to be too much careful with it. Having known that we've got different types of reactions. We've got those reactions that proceed, okay, with the gain of heat, and there are those that proceed with release of heat. There is some heat expended at the end of the reaction. So those reactions now will affect equilibrium differently, okay? Now, the effect of temperature on equilibrium depends, it will always depend on whether the reaction is endothermic. When the reaction is endothermic, then the change in heat is positive. Heat has been absorbed. Or it always depends on whether the reaction is exothermic. When the reaction is exothermic, it means that heat is given up to the surroundings, implying that DH is negative, okay? Now, if the reaction is endothermic, I've not yet given any example. I'm just still talking about the effect. If the reaction is endothermic, remember I've told you that for endothermic, DH is positive. So if the reaction is endothermic, right, then it means that increase in temperature favors it. Increase in temperature favors it. What does it mean? It means that if the reaction takes place with absorption of heat, then when you increase the temperature, it will favor it, because for it to increase, it needs high temperatures, meaning it has to absorb heat. Remember, I told you that Chatellier's principle is useful in a way that it tells us, or it allows us to shift equilibrium to the side that we would like to favor. So if the reaction is endothermic, increase in temperature will favor it, meaning that when they say explain the effect of heat, of increase in temperature on a certain reaction which is endothermic, you have to play smart. Then another thing we need to know that if the reaction is exothermic, now here heat is given out. I mean that now, if it is given out, then why do we need much temperature? So decrease in temperature favors that reaction. Decrease in temperature favors that reaction, or lowering the temperature will favor that reaction. So now, any change in temperature will change the position of equilibrium, rate of attainment of equilibrium, and also now the value of equilibrium constant will also be changed. Remember, for the previous factors of concentration and the pressure, the rate, the equilibrium constant value has not been changing. But we've said that for the case of temperature, the position will change. The position of equilibrium will change, right? Rate of attainment of equilibrium will change. Okay. And still, we said that the equilibrium constant value, regardless of the word constant, still it will change, right? So in this case, we have to also acknowledge that that for an exothermic reaction, increase in temperature favors backward. If the reaction is exothermic, remember we say that when it is exothermic, a decrease in temperature favors it, meaning that increase in temperature will now be favoring backward. So we have increase in temperature. When you increase the temperature, forward reaction will be proceeding with the decrease, but backward reaction will be favored by increase in temperature. Okay, for an endothermic reaction, this summary should stick into your mind. For an endothermic reaction, increase in temperature favors the forward reaction, while a decrease in temperature favors backward reaction. That is a simple summary I can make for you. Then let's have some sample question and we see. Okay, I'm going to have my equation: nitrogen gas plus hydrogen gas forming ammonia gas. DH is -92 kilojoules per mole. So we want to explain how the position of equilibrium, value of equilibrium constant, and the rate of attainment of equilibrium would be affected if the reaction is carried out at a temperature of 250. If the reaction is carried out at 250 degrees Celsius, the temperature 250 degrees Celsius and 10 atmospheres of pressure. What happens? Remember, the temperature was, we have 92, but negative, meaning that for forward reaction to take place, the forward reaction is exothermic, as you can see. The forward reaction is exothermic. Now, they say, actually, initially, they said that ammonia is formed from nitrogen and hydrogen at 25 degrees Celsius. Initially, it is 25 degrees Celsius and at 10 atmospheres. So they want us to explain the effect if the reaction is carried out at 250, but pressures remain the same, meaning they have increased the temperature from 25 to 250. Now, increase in temperature. We say that for this one being an exothermic reaction because of DH being negative, you need to first appreciate that this reaction is exothermic, simply because DH is negative. After having known that the reaction is exothermic because of DH being negative, then now, what about when we increase the temperature from 25 to 250? Increase in temperature does not favor an exothermic reaction, meaning that since the forward reaction was favored by this being negative, increasing temperature now will favor backward reaction. So when you're telling me the effect, first tell me that since the forward reaction is exothermic, since the forward reaction is exothermic, all right? Yeah, comma, increase in temperature from 25 initially to 250 degrees Celsius will do what? Will shift the equilibrium, from right to left, because initially it is exothermic, but you have increased the temperature. Yet exothermic is favored by a decrease in temperature. If they say the reaction was carried out like at 10 degrees Celsius, temperature would have been reduced, so it would favor the third reaction. So it will keep shifting from left to right. But now temperature has been increased, yet it was exothermic, so it will shift from right to left. That is what we need to first talk about. So this one favors backward reaction, favoring backward reaction, which is endothermic, which is endothermic. Now, since it has favored the backward reaction, it means that ammonia dissociates from nitrogen and hydrogen according to the Chatelier's principle, because it will adjust itself to shift to the equilibrium that is favoring it. Since it is being favored by backward reaction, everything now would be going backwards. So it means that ammonia dissociates, okay, to form ammonia dissociates to form nitrogen and hydrogen according to the Chatelier's principle. So if ammonia dissociates to form nitrogen and hydrogen, it means that the concentration of ammonia has reduced. This reduces the concentration of ammonia. The concentration of ammonia has reduced, but it has reduced the concentration of ammonia, but since it is dissociating to give these, now the concentrations of these ones are increasing, but increasing the concentrations of hydrogen and nitrogen, reducing the equilibrium constant value, reducing the equilibrium constant value. Now, the rate of attainment of equilibrium, the rate of attainment of equilibrium increases. Rate of attainment of equilibrium increases because increase in temperature, right, will increase both the forward reaction rate, and reverse reaction rate. Even though you say that the rate of attainment of equilibrium increases, okay, since the number of molecules or the number of particles in the reaction vessel increases, thus increasing the frequency of collision of the particles. So we increase both the forward reaction rate and reverse reaction rate, and hence the collision frequency between the colliding particles. As simple as that. So that is how the effect of increase in pressure does. Then, what if we consider this reaction? What if we consider this reaction? Nitrogen plus oxygen form nitrogen monoxide at DH 180 kilojoules per mole. If the question is, explain how the position of equilibrium, value of equilibrium constant, and rate of attainment of equilibrium would be affected if temperature was increased. If temperature was increased. Now, before you look at the effect, first see, is the reaction endothermic or exothermic? The reaction is endothermic. The reaction being endothermic, it means that pH is positive. So an endothermic reaction proceeds with an increase in temperature, meaning the word endo means in. So when you say endothermic, it means that thermo means heat. So it means that you're absorbing heat from the surroundings. So when temperatures increase, the system will keep absorbing heat. The system will keep absorbing heat. So that's why we say that when temperature is increased, it will favor the forward reaction of an endothermic reaction, or it will favor the forward reaction taking place in an endothermic reaction. So, increase in temperature will make the system, or will make the equilibrium to shift from left to right, because an increase in temperature favors endothermic reaction. So I would say, since the reaction is endothermic, since the reaction is endothermic, increase in temperature will favor, or increase in temperature will shift equilibrium, or will make the equilibrium shift from left to right. From left to right, full stop. Meaning favoring, okay, we can add on favoring the forward reaction, which is endothermic. Favoring the forward reaction, which is endothermic. Now it means that nitrogen reacts with the oxygen, okay, to form nitrogen monoxide, since the reaction is being shifted from left to right, meaning that is the position that is favored. So this one will keep reacting with this to produce this, right? According to the Chatelier's principle, implying that the concentration of nitrogen and oxygen will reduce, but the concentration of what is being formed, the nitrogen monoxide, will increase. Okay, increasing the equilibrium constant value. So we shall say that nitrogen reacts with oxygen to form nitrogen monoxide. This reduces the concentration, of nitrogen and oxygen, but increases the concentration of nitrogen monoxide, thus increasing the equilibrium constant value. The equilibrium constant value has increased. Still, the rate of attainment, of equilibrium, right, increases because increase in temperature, will increase both forward reaction rate, will increase both forward reaction rate and backward reaction rate. Forward reaction rate and backward reaction rate, or reverse reaction rate. This one you can call it reverse reaction rate. Okay. Increasing the rate of collision, increasing the rate of collision, frequency of the colliding particles, or between the colliding particles. That is what we are having. But if the temperature is decreased, what if they say temperature was decreased? Now, the fact that you know that endothermic reaction proceeds with an increase in temperature. If temperature is decreased, now the forward reaction will not be favored. Instead, the backward reaction will be favored. So now it will be shifting from right to left. If temperature is decreased, the equilibrium will be shifting from right to left, which is the backward reaction, meaning that nitrogen monoxide there will be dissociating. Okay, the nitrogen monoxide will be dissociating, and when the nitrogen monoxide will be dissociating, it will be forming nitrogen, and it will be forming nitrogen and oxygen. So the concentration of nitrogen monoxide will be decreasing, while these concentrations will be increasing, meaning that the equilibrium constant value will decrease. Equilibrium constant value will decrease, but the rate of attainment still here, the rate of attainment, for the case of the rate of attainment, will also decrease, because a decrease in temperature reduces the collision frequency between the colliding particles. As I told you, we are going to have some questions which we are going to work out that have these factors in them. So let's look at the effect of a catalyst. Effect of a catalyst. Effect of a catalyst. Now, when we talk about a catalyst, we are trying to mean that substance which alters. At our level, we shouldn't say catalyst is the substance which changes, or which speeds up, because some catalysts are negative and others are positive. So a catalyst is that substance which alters or which changes the rate of a chemical reaction, but remains chemically unchanged at the end of the reaction or at equilibrium. So adding a catalyst will alter the rate of a chemical reaction, but will remain chemically unchanged. So a catalyst, what you should know about a catalyst, it has no effect on position of equilibrium. So if they say maybe a catalyst was added to a reaction of dissociation of this, and they say, what is the effect of the catalyst on the position of equilibrium? No effect. Still, a catalyst has no effect on equilibrium constant, but it just alters the rate of backward and forward reaction. Equally, it alters the rate of backward and forward reaction, meaning therefore a catalyst increases the rate of attainment of equilibrium, by decreasing the activation energy. So a catalyst, basically, a catalyst increases the rate of attainment of equilibrium. Catalyst increases the rate of attainment of equilibrium, all right, by lowering the activation energy, lowering the activation energy. In the topic of chemical kinetics, I talked about the effect of the catalyst on the rate of reaction. It lowers the activation energy by providing an alternative path. Okay. So basically, that is it. That is it about a catalyst. Then the final point is the effect of adding a noble gas. Effect of adding a noble gas. Effect of adding a noble gas. Now, when you say noble gases or inert gases, okay, so addition of an inert gas or a noble gas to any equilibrium does not affect the constant value. It doesn't affect the constant value. Okay, so for example, what we can do, the noble gas effect or the effect of a noble gas is investigated under two conditions. We look at constant volume, or where the total pressure of the system increases, or at constant pressure where the total volume of the system increases. So to assess or to investigate the effect of a noble gas, we have to look into the detail of volumes and pressure. So the question is already set clearly for you. We've got like 2 molecules of carbon dioxide gas dissociating to produce 2 molecules of carbon monoxide gas plus 1 molecule of oxygen. So they are saying that explain the effect of equilibrium position, the effect on equilibrium position and equilibrium constant and the rate of attainment of equilibrium when argon is added, argon is an inert gas, is added to the equilibrium at constant volume. When they say at constant volume, it means that one can say when the total pressure of the system increases. So total pressure of the system increases. If they say at constant pressure, that is when the total volume of the system increases. Now, if we add argon, all right, at constant volume, argon being a noble gas, when added, it means that the total pressure of the system increases. That is what we need to first acknowledge. The moment they say constant volume, it means that the total pressure of the system increases. Argon being an inert gas. When they set constant pressure, it means that when an inert gas is added, then the total volume increases. But for this case, they told us about the constant volume, meaning that addition of an inert gas will increase the total pressure of the system. So the statement you need to first tell me is argon being an inert gas. Argon being an inert gas. Argon being an inert gas, when added, the total pressure of the system increases. The total pressure of the system increases. But even though the total pressure of the system increases, there is no change. There is no change in the partial pressure. There's no change in partial pressure, or there is no change in concentrations of reactants and products, implying that the position of the equilibrium, will not change. Though the total pressure of the system increases, the partial pressures or the concentration of the reactants and products have not increased. And if the partial pressure or the concentrations have not increased or have not changed, all right, then the position of the equilibrium is not affected. Okay, if it is this reactant, to keep like that. Now, since the concentration of argon doesn't apply in the expressions of Kc and Kp, then the equilibrium constant value remains unchanged. Okay, the rate of attainment of equilibrium, reduces. Why? Since some of the particles on collision do not react. Some particles on collision do not react, so the rate of attainment reduces. You say that there is no change in position, the equilibrium constant value remains unchanged, and the rate of attainment of equilibrium reduces. Yeah? Now, we need to note that when an inert gas is added to the system in equilibrium at constant volume, there will be no effect on equilibrium position, equilibrium constant value. Only the effect that will be there will be on the rate of attainment of equilibrium, whereby the rate of attainment of equilibrium is reduced. All right. So now, what about if they say that neon is added to the equilibrium at constant pressure? If they say neon is added to the equilibrium at constant pressure, when they say at constant pressure, it means that what changes is the total volume of the system, which increases. So total volume, you need to know that the total volume at constant pressure, total volume of the system increases. So if the total volume of the system increases, now we shall say that neon being an inert gas, when added, okay, when added to the system at constant pressure, the total volume of the system increases. The total volume of the system increases. So if the total volume of the system increases, now it means that the partial pressures concentrations of the reactants and products will decrease. You need to note all this will decrease. So according to Le Chatelier's principle, the equilibrium will be shifted from left to right. Okay, so the equilibrium when you carry the reaction at constant volume, rather at constant pressure, the equilibrium will shift from left to right. Okay, in that, or it will shift to that direction where there is an increase in the number of moles according to the reaction. So the equilibrium constant remains unchanged. The equilibrium constant remains unchanged. The equilibrium constant value remains unchanged simply because the partial pressures of the concentration of neon does not apply in the equilibrium constant expression. Okay, so the equilibrium constant remains constant since the partial pressure or the concentration of neon doesn't apply in KC or KP expressions. Okay. Yeah, so the rate of attainment of equilibrium will reduce as some of the particles on collisions do not react. So the rate of attainment of equilibrium reduces since some particles on collision do not react. So we have to note that when an inert gas is added to the system in equilibrium at constant pressure, okay, there will be a shift of the equilibrium position to the direction where the number of moles increases, but there's no effect on equilibrium constant value, and the rate of attainment of equilibrium will reduce. In our last lesson, I'm going to do you 1 or 2 questions to show you how all this that we've been talking about can be said to form a general question. See you there.